All right, hello everybody. Welcome to your Chapter 4 notes online. The main point of this video is going to be for you to have the notes, not really for me to explain it. Most of the stuff is pretty self-explanatory, but I want you to be able to have time to copy it down. So use this video as your chance to pause it and put your this in your notes. It's really important you put this in your notes. I probably am going to do a notes check on Thursday, so make sure you have this down. So let's begin with our transformations. First one is reflection. What we're doing this whole section is talking about the taking shapes in space and doing something to them. Most of them are going to come with words that we already know the definition of. So for example, reflection. We know reflections. We see that word all the time. In this one you see we have the original shape, ABC, and then we have our reflected shape, and it has like a little a thing on top of it, a little asterisk, a little prime symbol. So this is telling us this is our second shape, and this is our original shape. So make sure you're taking notes on these. Reflection, we have a line of reflection normally. You can see that right here. Line of reflection. Each point on the what's called the image, the pre-image and the image. This time we're reflecting over the y-axis. Sometimes we'll reflect over the x-axis, but in this case, we're doing the y-axis. We're going to add equations to this in the end, but right now I just want you to be familiar with all of the different kinds. Once again, if you need to pause at any moment, you can to write stuff down. I might be going a little faster than normal because you have the ability to control the speed. We have translation or slide. Translation is probably a word we think more about foreign languages, but translation is just moving an object. When you have something like in PowerPoint or in some other program, when you grab it and you move it around, that's translating. This is our pre-image. You can see the A with the little parentheses, B with little parentheses. This is telling us that's our new place, it's our new location. We have a certain way we move it each time. It'll tell us how to move it, and I'll show you that when we get to the equations part. But translation is basically moving it. We have rotation around a center of rotation. Normally that's the origin. And we have basically three different rotations. We have 90 degrees, which is shown here. We have 180, which is to the opposite quadrant, and 270. These are rotations. They'll always be around the center, but we have a rotation, a turn. That's another word we already are familiar with. And our final one is called dilation. If you've ever gone to the eye doctor, they might dilate your pupils. Dilation is basically make something bigger or smaller. We're going to talk about bigger more. And we have something called a scale factor. That's how much you make it bigger by. So we have a scale factor of 2, so you double it. A scale factor of 3, you triple it. So we have those 4 different ideas. And we're going to add some simple mathematics to it to help us understand how to do it. Make sure you have your notes fully ready on Thursday in case you have a notes check. It would be open notes if you do. So let's look at a quick example. This is the teacup ride in Disneyland, and you can see the teacups are moving back and forth. They are rotating in place, and they're also rotating around a rotating disc. So there's like 3 levels of rotation happening, but also they are translating from place to place. There is no reflection. Reflection is kind of difficult to model in the real world, but you see a very simple version of rotation here. This is in Epcot, still being built. This is the ride for the Guardians of the Galaxy. And you can see they are rotating while they are translating on the roller coaster. A little bit similar, a little bit different to the teacups. This one has a lot more translation of going from one place to the other, even rotating on a different axis as they tilt and turn. And you could almost think of that like a reflection. Not exactly, but yeah. So let's do a quick identify the following transformation as a rotation, reflection, or translation. You can pause the video before I give you the answer if you would like, but take a look at this one. This one looks maybe on first glance like a reflection across the y-axis, but if you look at where the corners are, they don't line up exactly. On the green image, on the image, not the pre-image is your blue, green is your after, the corners don't line up on the x-axis. So you can see they actually just moved it. They translated it a couple of places over. And they have the exact same slope. There are parallel lines to help you move it. If you look here, you have a kind of blue crescent moon, and then you have a green image after you've done it, and they are reflecting it across the y-axis. You could reflect across the x-axis. You could probably guess what that would look like, but we are just showing you an example right now of reflecting across the y-axis. You have an image of a triangle. You have a pre-image up there with it kind of sitting up. It tilts over. That is rotation. There's a rotation that is a 90-degree rotation. From one quadrant to the other, that one is 90 degrees. So identify the following transformation. You can see it is moved, but you can't change the orientation when it's just a translation. We won't be doing too many where we put them together, so this one is just a reflection. So let's get into the mathematics of it. I would pause this video to copy these down. You don't need the words as much. Definitely the symbols are really good, and we'll have one giant slide at the end with all of the equations. So you see here, when we're reflecting across the x-axis, you're going to match each piece on the x-axis, and then on the y, you're going to match each piece on the other side. So when we have reflecting on the x, we just turn our y values negative. We're staying in the exact same x position, we're just changing our y values to negative. Similarly on this one, we're just changing our x values to be negative. With translations, we're going to have something called a vector, which are basically an instruction manual on how to move it. So if our vector is 7, 4, that means take your whole shape, go over 7, add 7 to the x's, and go up 4, 4 to the y's. So move it 7 to the right, and then 4 up. That's what that translation vector is. It's an instruction manual on how to move it. And then we have rotation. We have a 90-degree rotation. We're starting here. You can see we're going to P prime right here. That is the P with a little accent mark. That is showing you we're going from the blue to the green. That's 90 degrees. 180 degrees, and then finally 270. When we go 90 degrees, we swap the positions of x and y. We make the y negative. In 180, we just make everything negative. Make everything negative, and 270, very similar to 90 degrees. And finally, dilation. We take our scale factor, and we just multiply every coordinate point by that scale factor. For example, on here, you have ABC, and if we're scaling it by 3, we have a scale. We'll multiply 2 by 3 to 6, 1 to 3, 5 to 15, 1 to 3, and so on. So the dilation is going to raise everything to that scale factor. You're going to multiply everything by that number. So here is your most important slide. This is everything kind of in one place. So if you get nothing else from these notes, make sure you get these. You have your reflections, one for the x, one for the y. You have your translations with your vector telling you how to move it. And you have your 3 different rotations. These are probably the hardest to kind of put in your brain, so make sure you have them in your notes. If I do give you a notes check, which I'm probably going to do Thursday, I will make it open notes, so make sure you have this available. And then finally, dilation, you have scale factor equals k, so it'll tell you your scale factor is this number. And you're going to multiply all of your points by that scale factor. We are going to be talking about animation all week, so hopefully this makes sense how it relates to animation, and we can use this as our vocabulary as we go along. Thank you very much. Hope this made sense. You have a worksheet that'll be due on Thursday as well, so go work on that.